One of the main assumptions of analysis of covariance is something called the homogeneity of regression. Let's just think about what we're doing. We've got the post-test scores. Now, for all we know, how well people do on the post-tests might just be pretty much a function of how well they do on the pre-test. So we need some way of controlling for that, and this is where analysis of covariance comes in. So if you think that the pre-test scores are very predictive of the post-test scores, then this is when we can do analysis of covariance. But what we need to check is that the pre-test scores are equally predictive of the post-test scores for all three of the groups separately. If we found that there's a really good relationship between the two in one of the groups but not in the other two groups, then that would cause us problems. So we're just going to check this. Right, so what I'm going to do a regression analysis. First thing I need to do is just split the data file so we can look at the results for the three groups separately. I'm just going to use compare groups, put training in. So the three groups, the three training groups, will be analysed separately and their scores compared. Now I'm going to do a regression analysis, just a linear regression. Put the post-test in dependent and the pre-test in the independent, because that's what we're predicting. Click OK. Right, so all we need down here, this is the coefficients. As we can see that for the training group that has no training, the control group, it's significant. It's also significant for the method A and significant for method B. What we need to look at is the unstandardized coefficients, or betas, the B's. This is the slope of the lines. So we need the slopes of the lines to be roughly the same for all three groups. So this is 1.1, this is 1.0, and this is 0.9. So they do look as though they are all roughly the same.